Question number 25, the question is from ray optics. Again, these sort of questions are regularly discussed in the classroom. So here is the situation that there is a plane mirror and there is an observer right here, and we have to see that what is the distance up to which the observer can view if someone is walking here, and you could say that this is twice as much as this. So essentially what we require is that this is a question related to a plane geometrical calculation. So here is the situation. This goes there, and upon reflection would come here. Similarly, this would go here, and upon reflection would go here. So this is the maximum distance that can be visualized. And this is also at the midpoint, so now the basic geometry has to be applied. Let's try to apply the basic geometry here. And this goes in this way. Now let's put the value. So if I put the value, say, all right, now if this distance is x and this distance is y, this would be x, then this would be x. And by all the property of the triangle, because that's an isosceles triangle, this would be x. And if this is x, this would be 2x. Similarly, this is y, so this will be y. And if this is y, this would be y. And subsequently, this will be 2y. So the coverage area is 3x plus 3y. And you can also see that x plus y is d, the length of the mirror. So therefore, the coverage area is 3D. Option number 2 comes out to be the correct option. Now, let's move to the next question. Question number 26. A bit of twist in modern physics, and the topic is Bohr's atom. You could say a particle of mass moves in circular orbit, and there is a different sort of field, but yes, the field is a central potential field. And notice another statement, if Bohr's quantization condition are applied, that means the same original quantization condition is still valid. We need to find how does the radius and energy depend on n. So the first thing is, say, if that is the potential energy, the expression of force, which is minus du by dr, and that comes out to be kr in terms of magnitude, and that will be equals to mv square by r, because that force is providing the necessary centripetal. And after that, what you do is that nh by 2 pi is mvr, the quantization principle. Now these are the two equations. You can solve for r and v. It's no different than the regular standard derivation, only for the difference that this time the force has become this much. You solve these things and you calculate the radius and the energy part. Option number 2 is going to be the correct one. Fine. Now let's move to question number 27. All right, question number 27. A next pick from an area which is not there in JEE Advanced. A question from electromagnetic wave. Let's see. It says a light wave is incident normally where the incident is there on a glass slab of refractive index 1.5. So the first thing I can do is n equals to c by v. 4% of the light gets reflected, and this is the amplitude of electric field of incident light. We need to calculate the amplitude of electric field of the transmitted light. So here what we'll do is say, I can write the intensity is half epsilon naught E naught square multiplied by c, where c is the speed of light in vacuum. So this is the intensity in the first medium. Okay. Now the transmitted one is 0.96 times I naught, and that will be half epsilon into E square multiplied by V, the same thing, because it goes into the medium, all right? And once it goes into the medium, so quite obviously, the epsilon is going to be epsilon naught multiplied by epsilon r, which is the relative permittivity of that medium, and V is the speed of light in that medium. And one more interesting fact. What you need to understand here is C is 1 by under root mu naught times epsilon naught, while if you go for calculation of V, that V is 1 by under root of mu naught times epsilon. So look at the difference. Speed of the wave in vacuum, speed of wave in medium. But in medium you could see the epsilon naught has become epsilon. Why didn't the mu naught become mu? The idea is very simple. For a very transparent medium, relative permeability is almost equals to 1. So these are the cases what you can do. By putting the value of C and V right here, you can find a relation between epsilon and epsilon naught. You divide it, so it's quite an easy calculation. And eventually, upon calculation, E you would find as 24 volt per meter. So for this given question, option number 3 is the correct one. So that required a bit of thinking. Now let's go to question number 28.